grade 2s, and welcome to Chapter 7, where we will be teaching you about money. Now, in this lesson, we will be talking about and using mainly Canadian coins, and we're going to be talking about American or coins from the United States of America, too. Now, in Canada, we have a lot more types of coins, but the United States has a coin that Canada doesn't have anymore. You see, a penny is equal to 1 cent. Pennies in Canada were used before 2012 and 2013. In some places it's 2013, in some places it's 2012. For example, here, I live in Ontario, so we didn't have pennies after 2012. I remember actually buying pennies in 2012 because it was the last year that the penny was used. Then, the next smallest actually, the one that's just bigger than the penny that we use in Canada is the nickel, which is 5 cents. The dime is 10 cents, the quarter is 25 cents, and the loonie, it's called the loonie because of the bird on the loonie, which is a loon, is 100 cents. A toonie is 200 cents. Now, America, the United States, does not have these two. 100 cents is also $1. 200 cents is $2. America has dollar bills. So moving on to the coins that the United States of America has, they have the quarter, 25-cent coin, the dime, 10-cent coin, the nickel, the 5-cent coin, and the penny, which Canadians don't have anymore. And the penny is 1 cent. You may say that there are technically half-dollar coins, which are 50 cents in America, but those are collectibles, which means that they are for people that collect coins. And they don't really use them in everyday life. But that's it for a crash course on different types of coins. Now let's move on to how to use those coins. First, we're going to work on the 3 smallest coins: pennies, nickels, and dimes. You can skip count to find the value of penny, nickels, and dimes, which is, how many pennies, nickels, and dimes do I need? You can skip count to find that. At least in grade 2, you can skip count. We will teach you a method in grade 3 on how not to use skip counting. Identify the coins you need to buy the object when you use the smallest number of coins. Write no if you do not use a coin. We have a 70-cent eraser. Should we use dimes, nickels, or pennies? And can we use dimes, nickels, or pennies? The answer is we can use dimes, we can use nickels, and we can use pennies. But because we are trying to use the smallest number of coins, we should first see how many dimes we need to use, because dimes are worth the most. Now you may be wondering, why do we want to use the smallest number of coins? Because very few people will carry around 70 pennies. Since a penny is equal to 1, if you skip count by 1, it's just counting normally. So if you want to pay for a 70-cent eraser using pennies, you're going to have to use 70 pennies. For reference, this is 294 pennies. Yes, I actually counted them. This is less than $3. And it's heavy. hope you heard that. Anyhow, because nobody really carries around that many pennies, how many dimes do we need, first of all? So for dimes, since it's equal to 10 cents, we skip count by 10. 10, 20, 30, 40, 50, 60, 70. That's, well, just correct. Just right. 70 cents? And we could have 70 cents completely in dimes. And that would take 7 dimes. So we don't need to use any nickels or pennies. We're just going to write no. What about a 25-cent bookmark? Let's start with dimes first. 10, 20, 30. Oh no, 25 is between 20 and 30, which means that we can't use just dimes. But we do need 2 dimes, because 20. 2 dimes, and then we start counting by 5s, because the next smallest unit that we count by is in nickels, and nickels is 5 cents, so that's by 5s. So it's starting from 20, 25. Oh, on the dot. Perfect. We only need 1 more nickel. And we don't need pennies, so no pennies. All right. What about for a 33-cent marble? Well, let's skip count, starting with the dimes. 10, 20, 30, 40. Okay, so 33 is between 30 and 40, so we only need 3 dimes. What about nickels? 30 would be no nickels, and then 35. But 35 is bigger than 33, meaning that we can't use nickels. So, no nickels. And pennies? Well, that's the only one we have left. So, 31, 32, 33. 3 pennies. A 55-cent pencil. Let's skip count by 10s because, well, dimes are 10 cents each. 10, 20, 30, 40, 50, 60. So, it's between 50 and 60, which means that we can only use 5 dimes if we want an exact number, since 6 dimes would be too much. Nickels, 50 is nothing, and then 55 would be 1 nickel. That's perfect. So we need 5 dimes and 1 nickel for a 55-cent pencil. And no pennies. Don't forget the no. Can you use dimes, nickels, and pennies? Yes, if it was a 59-cent pencil, then you would need 5 dimes, 1 nickel, and 4 pennies, because 2 nickels would be 60, and that'd be too much. Can you use only nickels and pennies? Yeah, if you had a 6-cent something, or a 8-cent something, well, that's really rare nowadays, but say it's 7 cents. Then, you can use 1 nickel and 2 pennies. That's 5 plus 2. And can you use only pennies? I mean, sure. Hopefully it's very low cost, or else you are going to end up with carrying too many pennies. Now, because remember my example of carrying too many pennies and I dropped the bag on the floor, now I have to clean up this pile of pennies. This is why nobody brings this many pennies to the store, because they can break the bag and when they drop, they create a mess. Now we move on to the next 2 types of coins. Quarters and half dollars, which you don't really use. So when you skip count for quarters, you have 25, and then you add 25, 50, add another 25, 75, 100. And for half dollars, it's just 50, 100. Because you're counting by 50. Now we identify the coins that we need to buy an object when you use the smallest number of coins. And we're going to write no if we don't use a coin, just like the last exercise. 100-cent yo-yo. Okay, so we should start by counting with half dollars, since half dollars is the more valuable coin, the coin that is worth more. So 50, 100. That's 2. We need 2 half dollars to buy a 100-cent yo-yo. And because we are not using quarters, no quarters. What about 25-cent gum? So if we count using half dollars, we have 0, and then we have 50. And 50 is too big, meaning that we can't use half dollars and we have to use quarters instead. So how many quarters is it? 0 quarters would be 0. 1 quarter is 25 cents, meaning that we would use 1 quarter to buy 25-cent gum. What about 75-cent crayons, or one 75-cent crayon? So we count with half dollars first. 0, 50, 100. 75 is between 50 and 100, meaning that we can use 1 half dollar. And from 1 half dollar, which is 50, if we use 1 quarter, we would get 75. So we use 1 quarter and 1 half dollar. For a 50-cent bandage, we can use 2 quarters. But we can also use 1 half dollar. And that is the least amount of coins. So we're going to use 1 half dollar instead and no quarters. Alright guys, in a lot of countries, you don't have the half dollar and you just have the quarter. In that case, you just use the skip counting quarters method, which is 25, 50, 75, 100, 125, 150, 175, 200, 225, 250, and so on, so on, so on. Note that the half dollar in the United States of America is mainly a collectible coin. It's for collectors, just like those special edition coins that you sometimes see. You know those special quarters that you sometimes get when you get change from the cashier and you look at them and you want to keep them? No? Just me? Okay then. Anyways, next section. Now let's count some coins. So instead of just skip counting when there's one type of coin, what about multiple types of coins? For example, here we're going to find the total amount of these coins. So we have a nickel, which is 5 cents, plus another nickel, which is another 5 cents, plus a dime, which is 10 cents, plus a penny, which is 1 cent. What do we get? Well, if we do some addition, we end up with 10 plus 10 plus 1, and then we end up with 20 plus 1, and then we end up with 21 cents. So really, the trick is to know what each of the coins is worth. Now count coins to check that there is enough money to buy the object. Answer yes or no. Here we have a 67-cent balloon. We have 3 nickels, which is 5, 10, 15, 15 cents, and 6 dimes, which is 10, 20, 30, 40, 50, 60. 60 cents. Add it together and we get 5 plus 0, 5, 1 plus 6, 7. 75 cents. We have 75 cents. Can we buy a 67-cent balloon? Yes, because we have more money than what we need. 67 is smaller than 75. What about a 28-cent hair clip with 10 pennies and 2 nickels? What's 10 pennies? Well, a penny is just 1 cent. So if you count by 1 for 10 times, well, that's just 10. If you don't believe me, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 cents. What about 2 nickels? 5, 10. Another 10 cents. 10 cents plus 10 cents is 20 cents. 20 cents is less than 28 cents. We need 28 cents, but we only have 20 cents. So we can't buy the 28-cent hair clip with 10 pennies and 2 nickels. What about here? A 90-cent highlighter. We have 3 quarters and 3 nickels. What's 3 quarters? 25, 50, 75. 75 cents. What's 3 nickels? 5, 10, 15. 15 cents. 75 cents plus 15 cents. We line them up. 5 plus 5, 10, regroup. 7 plus 1 plus 1, 7 plus 2, 90 cents. We have just enough money. We need 90 cents, and we have 90 cents. Meaning that, yes, we can buy the 90-cent highlighter with 3 quarters and 3 nickels. What about the 82-cent sticker? We have 4 dimes and 2 quarters. 4 dimes is, well, let's count by tens. 10, 20, 30, 40. 40 cents. And 2 quarters is 25, 50. 50 cents. Add them together, 0 plus 0, 4 plus 5, and we get 90 cents. 90 cents is more than 82 cents. Since we need 82 cents to buy the sticker and we have more than 82 cents, that means that we can buy the sticker. So yes. And there goes that section. You can take a break whenever you want, remember that, and remember to do your practice problems, because if you don't do your practice problems, then it's going to be very difficult to remember all this. Moving on. Section 4 is a problem-solving strategy, and today's problem-solving strategy will be, oh no. Now I'm sure you've heard me say this before, don't use this strategy, just don't. Because it's just not a good strategy. You have to use way too many things to act it out. You might as well just draw a picture instead. It probably takes less time, it probably takes less things, and it's just, no. But I still have to teach you it. Ozzy has 12 buttons. Each of them costs 5 cents. How much do the buttons cost in total? Okay, I'm just going to use my pennies. Remember that bag of pennies? Yes, they're still here. I've cleaned them up. So, let's just say that each of these is a button that costs 5 cents. What do we know? We know that each button costs 5 cents and there's 12 of them. And what do I need to find out? How much do the buttons cost in total? Legitimately, which means truthfully, if you buy collector's coins, they're going to cost more than the coins themselves. For example, if you try to buy a penny in Canada right now, then you're probably a person who collects pennies, and they're probably going to sell for at least a nickel, depending on how old the pennies are and how limited edition the pennies were. So here I have 12 pennies in my hand, which I'm trying not to tip off. And here's how you would act it out. Oh, 12 pennies. Let's count. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Woo! I've counted 60 cents. The buttons cost 60 cents. You could also write cents out. In total. Really, you could have just skip counted using your fingers. You don't need to act things out. If you act these, first of all, you probably won't get these during an assessment or a test or a quiz. And, well, I'm pretty sure your teacher won't appreciate you ripping away at your test to make tokens. If you have to visualize something, draw a picture. It's probably faster. Anyhow, let's check our answer. Make sure the information is correct. Ozzy has 12 buttons. Okay, 12. We did count 12. Each of them is 5 cents. We counted by 5. Make sure your math is correct. Well, we did count them all out. And if we want to count them again, I'm just going to use my fingers. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and oh no, I've ran out of fingers. Let's add 2 more. This is 110. 55, 60. Yay, we've counted correctly. So our math is probably fine. We didn't really do math, but we also did math. Counting is math, except it isn't what most people traditionally think of math, because when they think math, they think calculations. Now the last step is to make sure that you answered the question. How much do the buttons cost in total is the question. And did we answer it? Yes, because our answer is the buttons cost 60 cents in total. You might be able to tell that I do not like this strategy, and you will hear me ranting about it for many years to come. Yes. Anyhow, now that we're done and over with that strategy, let's move on to the next section. Remember that you can take a break whenever you want. Alright, so now we're going to teach you the concept of a dollar. You can use different coins to make a dollar. So, a dollar is equal to 100 cents. So a dollar is equal to how many pennies? How many pennies is 100 cents? 1 penny is 1 cent. So that's 100 pennies. What about nickels? Since a dollar is 100 cents and a nickel is 5 cents, and you haven't learned division yet, let's skip count until we get to 100. So we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. That's 20 tally marks. So it'd take 20 nickels to get a dollar. How many dimes would it take? Let's skip count. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's 100 cents, which is a dollar. So it's 10 dimes. What about quarters? Well, quarters is 25, 50, 75, 100. You only need 4 quarters. Half dollars? Well, it's called half dollars for a reason. 50, 100. You only need 2 to get to $1. What about a dollar bill or a dollar coin, which is called a loonie in Canada? Well, it's called dollar bill or dollar for a reason. So we only need 1 of those to get $1. So $1 is equal to 100 cents. For those of you that really want to see this in a sentence. Okay, let's circle some coins in each group that equal $1. So we have, in the first group, nickel, dime, quarter, penny, quarter. Together, this entire group is actually more than $1. We need to find coins in each group that together equal $1. So how can we make $1? We can make $1 with 4 quarters. But we only have 3. How else would we do it? Well, we have 3 quarters only, but we have 2 dimes and a nickel. 2 dimes and a nickel is 10, 20, and a 5. And that's 25. What does 25 cents also equal to? 1 quarter. So that's 4 quarters, technically. Let's circle these coins. To check it over, we can do, okay, so nickel, 5 cents, dime, 10, quarter. What's 15 plus 25? It's 40. Another dime, that's 50. Quarter, 50 plus 25, 75. And then another quarter, 75 plus 25, 100, which is 100 cents, which is $1. Okay, so the second group might be a little bit more tricky. Dime, nickel, dime, penny, dime, nickel, dime, penny, dime, dime. Oh dear. Now we have no quarters this time. So we might need to rely, well, we will need to rely on good old dimes to do most of the heavy lifting because they're worth the most. So how many dimes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, there's 9 dimes. Since a dime is 10 cents, how can we make a dime with nickels or pennies? Well, we could have 2 nickels, which is 5, 10 cents, or we can have 10 pennies, or we can have 1 nickel and 5 pennies, because that's 5 plus 5, which is 10. But we don't have 5 pennies. We have 1, 2, 3, 4 pennies, which means that we will have to use nickels only. And we can use 2 nickels, which we do have. All right, let's circle these. Dime, 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 dime. To check it over, 1 dime, 10 cents, 1 nickel, 15 cents, another dime, 25 cents, another nickel, 30 cents, another dime, 40 cents, another dime, 50 cents, another dime, 60 cents, another dime, 70 cents, another dime, 80 cents, another dime, 90 cents, and the last dime, 100 cents, which is $1. Okay, now dime, quarter, dime, penny, nickel, penny, dime, penny, quarter, penny, nickel, dime. Okay, how many quarters do we have? Usually, in coins, you want to fill up your number of coins the least. So you want the least amount of coins. And to do that, you will need high value coins. So coins that are worth a lot. In this case, the highest value coin is the quarter. So we have 2 quarters. That's 50 cents. Now we need to make 50 cents because 100 minus 50 is 50 with the rest of these. Well, how many dimes do we have? We have 1, 2, 3, 4 dimes. Okay, so 50 minus 40, which is the 4 dimes, is equal to 10. Do we have 2 nickels? We have 3 nickels, in fact. We also have 5 pennies. So we can use a nickel and 5 pennies, or just 2 nickels. Since usually you want to carry around the least amount of coins because coins are heavy, we're just going to use 2 nickels. Now let's circle these coins that we underlined. So we could check it over by technically skip counting. Dime, 10 cents quarter, 10 plus 25, which is 35. Another dime, 45. Another nickel, well actually no, first nickel, 50. Another dime, 60. Another quarter, 60 plus 25 is 85. Another nickel, 85 plus 5 is 90. And another dime gives us 100 cents, which is $1. Hooray! Now what about question 4? We have loonie, dime, quarter, nickel, penny. Now you may be looking at dime, quarter, nickel, penny and saying, wait, I can't do anything with that. But remember, a loonie is a Canadian dollar coin. So a loonie is $1. Okay, so that's what we have for this section of the dollar. Let's move on to the next one. Now that we've dealt with dollars, what about dollars and cents put together? So you can use this very interesting little thing called a decimal point to show dollars and cents. For example, $1.56 can be written as 1 decimal point or $1.56. Now, what's in these points can go up to 99, which is 99 cents. And just like regrouping, if there's 100, then it's 1.00 because there's $1 and no cents. Now let's circle the coins in each group to match the written amount. We have $2.76. I can tell by 2.76. So everything to the left of the decimal point is a whole number, and everything after that is smaller than a whole number. And in this case, the whole number is $1. So we have $2.76. How will we get the $2 first? Well, we have a toonie right here. A toonie is $2. Okay, so that's the $2 down. What about the 76 cents? Okay, so first, what's the next biggest coin that we have? A loonie. Well, a loonie is a little bit too much because you see, a loonie is an entire dollar. 76 cents is less than 100 cents, which means that it's less than $1 because 100 cents is the same thing as $1. So we can't use a toonie. Next, it's a quarter because nobody really uses half dollars. So we have 3 quarters here. 3 quarters is equal to 25, 50, 75. So it's 75 cents. And how much more is 76 cents when you compare it to 75 cents? Well, it's 1 cent more. 1 cent is a penny. Do we have pennies? Yes, we have 2 pennies, which means that we can use 3/4 and a penny to get 76 cents. And we're going to use a toonie for the $2. That would work. Now for $5.29, or $5.29, what can we use? Well, first of all, we need the $5. We have a toonie here, which is good because a toonie is $2. And after $2, we still need $3 more. Do we have another toonie? No. But we have 3 loonies. 1 loonie is $1, so 3 loonies would be $3. That's the $5 down. What about the 29 cents? 29 cents can be made in many different ways. The one with the least amount of coins would involve 1/4, which is 25 cents. So what's 29 minus 25? It would be 4 cents. And 4 cents would be 4 pennies, because we can't use a nickel for 4 cents if we want exact and not rounded. Do we have a quarter and 4 pennies? Yes, we have 5 pennies, in fact, but we don't need 5 pennies. So we're just going to circle 4 pennies and the quarter, because we only need 1/4, remember? And that's it. We have our $5.29. $3.60. Okay, so $3. How do we make the $3? And there's also the 60 cents. How do we make the $3? Let's look at the biggest coin in the group. Oh, we have a toonie. That's good. And we also have a loonie. That's $2 plus $1, which is $3. So toonie, loonie. That's the $3 down. What about the 60 cents? Do we have quarters? That's a big question. When you try to get a value, use the biggest coins first. Unless you're trying to spend all your little coins. I've done that before. Once I ended up having too many coins and I had to spend them. That was before coin collecting. And so we have quarters. That's good. We have 2 quarters. 2 quarters is 25, 50. Is 50 smaller than 60? Yes, which means that we still need more coins. But what coins do we need? Well, 60 minus 50 is 10. So when 60 minus 50 is 10, what coin is equal to 10 cents? A dime. Do we have a dime? Yes, we have 2 dimes, in fact, but we only need 1. And with a dime, a quarter, and another quarter, we get the 60 cents down. That's it for this section. Next section will be about comparing values. Well, comparing values of money, because we've already learned comparing normal numbers. What about money? So when we compare money amounts, it's just like the do we have enough money to buy this? So we count the money that we have and we compare it to the price. Such as yogurt costs $1.25 or just $1.25. Is there enough money to buy yogurt? You have a quarter, a dime, a quarter, and a loonie. So that's 25 cents plus 10 cents plus another 25 cents plus 100 cents. Don't add just $1 in because you have to keep the units the same. And that is 50 plus 10 plus 100, which is 60 plus 100, which is 160 cents. And 160 cents is equal to $1.60. That is more than $1.25. Just like in comparing normal numbers, you look at the biggest place value and then you move continuously towards smaller place values. And smaller place values are to the right side of the number. Now let's count the money and circle the group that is more. Here, we already have the money here, so we have to count this blob of words. We have a quarter, that's 25, plus a loonie, which is 100 cents, plus a dime, 10 cents, nickel, 5 cents, another dime, 10 cents, another penny, well, our first penny, because there's another penny back there, 1 cent, another nickel, 5, another dime, 10, and another penny, 1. Okay. I'm just going to add these two together because why not? We have 125 plus, there's 3 tens, so that's 30, plus there's 2 fives, so that's 10, plus there's 2 ones, so that's 2. And that would be 125 plus 30. You could do this in any order you want, because then again, this is addition, and the commutative property of addition says that we could do addition in any order we want. Plus 12, which is, I'm going to show you how to do this. This is more than 2 digits. You line up the ones digit and you line up everything else, and you just do it normally. Start from the right, move to the left. 5 plus 2, 7, 5 plus 1, 6, 1 plus nothingness, 1. And you get 167. Is 167 bigger than this is, because we're doing this in cents, 207? No, it's not. Meaning that you don't have enough money to buy whatever this is, and you really need more money if you want to buy that. Anyhow, there's also 65 cents and this blob. This blob is a quarter, 25, plus a toonie, which is 200, because 2 100s is 200, plus a dime, which is 10, that looks, anyhow, plus a nickel, which is a 5. And from that you get, well, what's 25 plus 15? 40. 200 plus 40, for those that that's 240. Is 240 cents, remember this is all in cents, makes sense, right? Haha, bad jokes. Bigger than 65 cents? Yes, 240 is bigger than 65. If they're the same unit, which they are. If it was $65, then that would be a different problem. But they're both in cents, and 240 is bigger, so this group is bigger. Now, $1.97, which is 197 cents, versus nickel, 5, dime, 10, quarter, 25, dime, 10, quarter, 25, dime, 10, nickel, 5, penny, 1. So that's 2 25s, which is 50, because 25, 50, plus that's 1, 2, 3, 3 tens, which is 10, 20, 30, And then there's 2 5s, which is just 10. And then there's 1. 50 plus 30 plus 10 is, well, that's 5 tens plus 3 tens plus 1 10, which is 5 tens plus 4 tens, which is 9 tens, which is 90, plus 1, which is 91 cents. 91 cents is much smaller than 197 cents. Make sure that the teacher can tell your numbers apart from each other. So, $1.97 or $1.97 is more than this bunch of coins. Okay, moving on. 86 cents and dime, quarter, nickel, quarter, quarter, penny, dime. All right. 10 for dime, 25 quarter, 5 nickel, 25 quarter, 25 quarter, plus 1 for penny, plus 10. Okay. There's 3 25s, and that's 25, 50, 75. There's 2 10s, that's 20 because 10, 20. There's 1 5 and 1 penny, so 1 1. All right. Now you may have noticed that 20 plus 5 is equal to 25. So 75 plus 25 is 100. 100 plus 1 is 101 cents. And that is bigger than 86 cents, meaning that this group of coins is bigger than the value written right here. Now that we've counted our coins, we're going to add some more money. You can take a break whenever you want during this chapter. Remember to do your practice problems. Adding money really isn't all that different from adding normal numbers. It's just that some types of adding money is a little bit different. Now we have our first type with cents, and our second type using dollars and decimal places. Our first type using cents is really just line up the ones place and add. And there's 4 plus 7, which is 11, and you regroup, and you get 1 plus 5 plus 2, which is 5 plus 3, which is 8, and you get 81 cents. Really, it's not all that different, except that you have to write a cent sign. But here is where things get a little more complicated. You have to put the dollar sign. You write 0.32. But instead of lining up really anything, you have to line up the decimal point. You don't you do line up the ones place because the ones place is the one immediately to the left of the decimal point. But you line up the decimal point specifically. Don't mind anything else. Don't mind any of the other numbers. Just the decimal point. Because if you line up any other numbers, you might end up with your place values not lining up correctly. And then you just start from the right and move to the left. 2 plus 6, 8, 3 plus 4, 7. Here's where we need to pay attention. When you add or subtract using decimal points, you have to drag the decimal point down, and it stays in the same place. It does not magically move in addition or subtraction. Okay, we move on after we put the decimal place in the correct place. 0 plus 0. And then dollar signs. Alright. What we really need to remember is the cent sign, if we're using the cent method, or the dollar and decimal point, if we're using the dollar and decimal point method. Remember to put them in your answer, or else you might end up with some embarrassing things. And, well, you calculated it all correctly. You just forgot to put the cent sign, and the teacher's looking at it going like, do you mean cents or dollars? Even though, you know, sometimes you're like, of course I mean cents. Well, you didn't write it down. Because sometimes in life, if you don't write it down, then it's not true. The power of words. Anyhow, let's add some money. Here we have the cent method. So we just line up our ones places. And 1 plus 0, 1, 3 plus 2, 5. Don't forget the cent sign. And we get 51 cents. Here we have the dollar method. Line up the decimal points and add from the right, just like we normally do. 5 plus 1, 6, 6 plus 3, 9. Drag the decimal point down to where it's supposed to be. 0 plus 0. And don't forget your dollar sign. And we get $0.96. Now, of course, when you're using the dollar decimal method, you can do something like this. You can drag the decimal point down before you do any calculations. And then you start from the right hand, you get 2 plus 6, 8, 3 plus 4, 7, 0 plus 0, dollar sign. Don't forget your dollar sign or your cent sign, and never forget your decimal place, because the decimal place is very important. Don't worry, guys, you'll keep learning about decimals in the future. This is the cent method, which is the one that you just line up the ones place and be done. Well, not exactly done, but 8 plus 9, 17, you have to regroup, and then 1 plus 7 plus 1, 7 plus 2, and that's 9. And you get 97 cents. Hooray! Now you thought that adding money was weird? Let's subtract now. Just like how adding money is like adding normal numbers, subtracting money isn't really all that different. You just need to remember to line up the decimal point. Now when it's in cent form, you just line up the ones place and subtract. Just don't forget the cent sign. 5 minus 0 is 5, and 4 minus 1 is 3. And that's 35 cents. What about $0.42 minus $0.22? Well, you line up the decimal point and you just subtract, starting from the right, just like we normally do. 2 minus 2, 0. 4 minus 2, 2. Remember to drag the decimal point down to the same place. 0 minus 0, 0. And don't forget your dollar sign. I'm going to underline this sentence just so you remember. Let's do some subtracting. So our first subtraction is the dollar decimal place form. So we have $0.92 and $0.55. Remember to line up the decimal point. Okay, 2 minus 5. We need to regroup for that. So we regroup from the digit that is immediately to the left, which is 9. 9 borrows 10 to the 2, so it's now 12. 12 minus 5 is 7. 9, because it's been regrouped, is 8 now. 8 minus 5 is 3. You drag down the decimal point, 0 minus 0, 0, and you don't forget the dollar sign. So this is why most of the time when you regroup, you don't cross things out, because we don't really have the space to do much. Now, it's in the cent form. 68 cents minus 19 cents. We line up the ones place, and we move on to subtracting. 8 minus 9. Well, that doesn't really work. We need to regroup. And we get 18 minus 9. That's 9. 6 got 1 regrouped out of it. It's 5 now. So 5 minus 1 is 4. Don't forget the cent sign because this is cent form. And you get 49 cents. 73 cents minus 47 cents. Line up the ones place. And move on to subtracting. 3 minus 7 doesn't really work, so I regrouped and I get 13 minus 7, which is 6. 7 got 1 regrouped out of it. It is now 6. 6 minus 4 is 2. We end up with the difference of 26 cents. And over here we have our dollar decimal point form. We line up the decimal points and we subtract. After we line up the decimal points, we start from the right. We get 9 minus 4. 9 minus 4 is 5. We don't need to regroup. And then we move on to the left, which is 4 minus 1, and that's 3. We drag the decimal point down to the correct place, and we have 0 minus 0, which is 0. And don't forget the dollar sign. We end up with a difference of $0.35. Okay, so that's subtraction. Now we are going to move on to some problem solving. For our last problem solving investigation of this chapter, we get to choose a strategy. There are 36 cookies in a pack. Amy and her friends eat 12. How many cookies do they have left? Well, so step 1, we need to understand the question. What do I know? So there's 36 cookies in a pack, so that's what we start with. And 12 are eaten. What do I need to find out? How many cookies are left? When it says how many cookies are left, usually you would do subtraction. So here, how about we write a number sentence or just math? A lot of math will involve writing number sentences. So here I go. 36 is what we start with. We take 12 out, or we eat 12. Well, not we, Amy and her friends. And what do we get? 36 minus 12 is 6 minus 2, 4. 3 minus 1, 2. 24. They have 24 cookies left. That's our answer. Now we check our answer. Is our information correct? Is our math correct? And did we answer the question? So information, 36 cookies in a pack. That's what we started with. Amy and her friends eat 12, so we take away 12. How many cookies do they have left? They have 24 cookies left. So our information is right, and we answered the question. But is our calculation right? 36 minus 12, 6 minus 2 is 4, 3 minus 1 is 2. So that is 24. So our answer is correct. Now, that's it for Chapter 7. Hooray! Don't forget to do your practice problems and your homework. Now, I'll see you in Chapter 8.